Hi, I'm Corey Williams from Centrify. I'm joined today by Paul Moore, who is a CTO and a co-founder of Centrify. And we're here today to discuss a little bit about SAML, what it is, how it can be used, and why you should care. So as I talk to customers and as we interact with a lot of people, they've heard of the term SAML, but they don't know quite what it means, what the single sign-on process looks like, why it might be important to them. Is that something you can help explain for us today?
I'm just going to go up to the board and sort of lay the overall framework of what SAML is trying to do. Okay, so SAML covers a lot of use cases. What I'm going to talk about is the use case that seems to be coming into use now, which is where we've got a multi-tenanted SaaS service, and we want to be able to use that. There are cases that came up before SaaS things existed, but the SaaS one is a very clearly understandable case and is the main use case you see today. So I'm going to imagine that we have some cloud service over here, which, let's say it's some online CRM system, which provides multi-tenanted services to businesses who use it. By multi-tenanted, I mean all sorts of companies use the services of that, and it feels to them like they own a slice of that.
So this could be Salesforce, NetSuite, Concur, WebEx.
Those kind of services, yeah. And what we have over here, so this is Salesforce, let's say, and over here we have a customer. I'm drawing a very high level here. That just doesn't represent anything technical. So we have customer one here, and they have a user population who want to access the services of this Salesforce. The classic way that would be done in the pre-SAML days would be that the CRM system would have a big database of users and passwords and other information about users, maybe their rights and so on, but let's just focus on users and passwords. And then when somebody from customer one tries to sign in, so here's a customer one user, he signs in, and when I connect to here, this system would look in the user password database to see, am I a user, which tenant do I belong to within Salesforce, and whether I should be allowed in or not. It's a standard way you would do things, and in fact it doesn't differ that much from how an on-premise system would work. There's the additional complexity of the fact that this system has to divide itself up into pieces, but the authentication mechanism is just like it was an on-premise system. So when the user logs in, his user password is sent to this application, and the application verifies it against its own user password database. There are a few problems with this. Each player in this game has their own set of problems they need to deal with. So if we just look first of all at the administrator, so this is the customer site here. We look at the administrator of this customer. His problem is that if this user, let me just draw, here's our administrator here, and here's the end user. If this user leaves the company, C1, we no longer want them to have access to this data, to whatever data it is inside here. The problem is that this person here, this administrator, has no control over, or maybe even no visibility directly into this thing. And maybe they could go and do it by hand to this one thing, but imagine that really C1 is using multiple SaaS services, having to keep track of which ones this user can use, very quickly adds up to quite a complicated problem. So
it becomes sort of a fire drill for the IT administrators to find out all of the services he has access to, right, and then go and figure out how to get them out of those systems.
Right. I mean, he really wants just to have one switch to say this person no longer works here. I mean, and there's also more subtle ones, which is, let's say this person changes job role. You might need to change some permissions or something about them over here. And again, because this isn't integrated with the systems over here, it doesn't work, it doesn't flow very well. There's no way of doing that. This person's view of the world is now, well, I've got a different user ID and password I have to remember here, right? And again, I've only got one, but again, more and more companies are using different SaaS applications. Maybe this person's using 5, 6, 7, 8 different SaaS applications. Maybe they have the same user ID, maybe they don't. It's easy to lose track of what you've got. So they're inconvenienced by it. And then over here, I'm going to draw one person, what this person's view of the problems are. I mean, of course, I mean the owner and builder and engineers creating this service, they have to deal with the fact that now they're maintaining a user password database, which in itself is a big security liability, right? If you follow the press, there's all sorts of things, you know, another 10,000 user names and passwords were leaked somehow. They'd rather not have to manage all the infrastructure of doing that. And then also dealing with all the complaints that, so for example, these people keep forgetting their users and passwords, so now we have to run user password reset capabilities here. There's just a whole bunch of engineering that they don't want to deal with. These people are focused on being an awesome CRM system. They don't want to have to worry about the security aspects of it. So although it works, none of the players in the game are actually happy with their results. So this is what SAML is trying to solve, and in fact successfully solves. So let me show you a revised flow now of how that would work. So we presume that this customer, let's suppose they have Active Directory. Nothing particular about Active Directory, but as we know, it's a very common directory system. So I have over here AD, and this is of course managed by my administrator. And somewhere up here we have something called an identity provider. We'll look later on in detail about how that's implemented, where it works, but something which is connected to this system here. So what happens now is when this user wants to log on, what they do is they connect here first. And this system knows who this user is because they're vouched for by the company's Active Directory. It knows, and we'll come back to how all it knows, that this user wants to connect to Salesforce in our example. And so what this system does is it issues a token to the user which describes the user. The main thing it says is this is user 1. And this is then sent to the Salesforce. This token is sent over here. Now, this system...
Does that token contain, I'm assuming it contains information about who the user is so that the CRM system knows, but does it contain like the password for the user to get it in?
No. So as I said, the primary thing is it says in a trustable way, we'll come back to how it's trusted, that this system asserts that this user really is Jane at acmewidgets.com. And then this information flows up here, and this system knows for sure that that is Jane at acmewidgets.com. And now this system allows Jane to do whatever she needs to do within that system without having to know about his user and password. And as we just pointed out, the password doesn't flow up there. There's no password database over here. So now everybody's much happier because the administrator can simply disable a user in Active Directory, and now the identity provider will no longer issue these tokens on behalf of users that are no longer employees. Jane's life is simplified because she just has to log in once to this system with the same user and password as she would use to get to Active Directory, which is the one she uses for in-house resources as well. And the people at the Salesforce side of things no longer have to worry about maintaining potentially leakable databases of users and passwords. So another interesting thing, while we're just looking at the SAML token, we definitely have in here the user. So we said this is Jane at whatever. We can put other information in there. So we could, for example, say what groups she belongs to. We could job grade, any sort of information that might be useful and meaningful to the target application. So, for example, you might get different permissions inside here depending which department you work for. So if you work for the sales department, you get one set of rights in here. If you work for the marketing department, you get a different set of rights in there. And this token can contain more than just your identity. It can contain information about you. And the identity provider is configured in such a way that it knows for each application that you're going to talk to which pieces of information need to be sent to the final application.
Now, one of the things that I've noticed is that you've changed the normal place that a user logs into by having them go to the IDP first. Is that the only way to do it? How does that affect the end user?
Excellent question. So, yeah, and this one I've drawn, again, just to kind of get our feet wet, is where the user has explicitly come to the identity provider. A very common mechanism, and maybe even a more common mechanism, is where the user goes directly to the application. The most common case clearly there is somebody sends them a piece of email. They click on it, or maybe they have some bookmarks. They click on those, which have the URL of this destination. Now the user arrives, and what happens is this service will detect that I don't know who this is. There's no tokens connected in there, either a SAML token explicitly or some other tokens, cookies, or whatever that this service may have used. I don't know who this is, but it can tell who the user has come from. So it knows that this is a user of this customer, and so
and it might know that because it's acme.crm.com,
yes,
as opposed to just going to www.crm.com. Or it might ask them.
It's a classic problem of SAML called realm discovery.
Okay.
How do I know a user I don't know arrives at me, and I have to send them back to their home, right? And so I've got this chicken and egg problem. I need to find out who they are, but to find out who they are, I need to send them back to their home, but to find out where to send them back to, I need to know who they are. So a very common situation, just to expand on what you just said, is that in a multi-tenanted system, you might have crm.com, but that might be set up actually as acme.crm.com for the tenant called Acme. And in that case, if a user arrives at that URL and they don't know who it is, then they will convert this name here to some destination over here. Or as you pointed out, they might even ask them. Or another common one is you ask the user just to enter their name, but don't ask for a password or anything, and simply then, based on the name they've entered, redirect them. I've seen all
I've
different
experienced
types.
both.
Yeah. But so somehow, by hook or by crook, this system works out where your home is, and so you then get redirected back to here, which will then sign you in again. And again, depending on exactly how these work, you might get silently authenticated, which we can discuss a little further later. Or you may be prompted with the user and password, or maybe the IDP's already got you logged on via cookies and things, and it's remembered who you are. But importantly, at this moment, it can still verify you're still a valid user. And then it issues a token, and you'll then be redirected back here with your same SAML token. So the user experience in general in that case is they'll open a URL, they'll see maybe the title bar of the web browser go click, flick, flick, flick as it gets redirect here, redirect back there. If they're already authenticated to the IDP, they won't see any further interaction. They don't have to do anything. If they're not authenticated to the IDP, they might be challenged for a user and password here. And then they'll be smoothly routed back to this one. So let's throwing in some terminology. This is what's called SP initiated.
So the SP is the
service provider.
So
this is
the application or resource I'm
the
trying to
thing
get
providing the service,
okay.
Right? So this is called SP initiated because the authentication flow is initiated by the user landing here. This one I drew first is called IDP initiated because the user started out by talking to the IDP. The IDP was the one that decided, oh, we need a SAML token, and then sent you off over there. And some SAML applications only support IDP initiated, don't support SP initiated. It's a little more complicated, as we saw, because of the realm discovery problems. This one is very easy to implement. The IDP initiated is very easy to implement for a service. So there are none the other way around that I come across which they support SP initiated but not IDP initiated.
Now, once the user has authenticated through either of these mechanisms or processes, From that point forward, do they have to go through this again, or do they get to continue to access that resource? How often do they have to go through this redirection?
So there's two aspects of this. So one of the things there's a kind of little mini elephant going on here, which of course is there are other services over here. So we've talked about service 1. So over here we've also got service 2, service 3, service 4. Right. Other services. I know this wasn't exactly what you're asking, but I think it's an interesting point, is that this user now, when we first went here, somehow we ended up being authenticated here. When the user now goes off to this second service, they're not asked to re-authenticate by the IDP, unless the IDP wants to get very fussy, but there's no requirement. So once I'm authenticated once to my IDP, I can go to all of the services I need to use without having to authenticate again. However, then there's the inverse problem, which is eventually we do want to make sure that the user's still an employee. We don't want, okay, you authenticated once, 3 years later, I'm still using the same access, right? That kind of blows away the original problem we had here, which was this person wants to be in control. So what happens there is when in the SAML token, there's another thing in here, which is, excuse my confusion of colors here, is the lifetime of the token. So it might say 2 hours. And what that means is when this token is received by this service, it will go, okay, this token is valid for 2 hours. At the end of 2 hours, it will redirect the user back via this process back through here. And again, in general, it will silently reissue the tokens, just like we did the first SP initiated one, and simply flow back there, and you'll get another 2 hours. The user might see again his address bar flick a couple of times, but the experience is usually seamless. For those of you that know Kerberos, Kerberos has a similar idea, which is Kerberos tokens which are renewable, but also have expiry times on them. So you can keep on renewing them. People go, if I can keep on renewing them for as long as I like, why even bother having an expiry time? The point about it is, it expires after 2 hours, but it's still renewable. The system will automatically reissue another one, but it still verifies that you're a valid user. It just makes you come back to the definitive identity store every now and then. Okay, so what I'm going to do now is wipe this off and just talk about in detail just a little bit of how I drew arrows showing how tokens flowed backwards and forwards. And that brings us to the topic of, I'm sure people have seen these things talk about active profiles and passive profiles and things like that, and how does some of that magic work, and what does it mean, and what are the use cases, and so on. So I just wanted to get rid of a lot of those arrows and so on, and start again. So we'll come back to our let's call it Salesforce. And so the first use case we had was we had a web browser with a user wanting to access it, and we had a complicated flow going on. The user wanted to connect, but then this thing redirected somewhere else, so we had the IDP over here, so the user connected over there, and then I got redirected to here, then this thing redirected me back again. That whole flow between these three players, and sometimes even more players, is called the passive profile. This is using SAML speak. Let me just step back a little bit. SAML covers two things. So the first thing that SAML talks about is the payload format. So remember I drew a picture of a token and said it contains your user identity, expiration times, various attributes of the user, department, and so on. So the first thing that SAML describes is the content of that payload, and just as an FYI, that's an XML payload, a whole bunch of ASCII angle brackets, with it's signed in particular ways and so on. So the first part of the SAML specification describes just the contents of that. It doesn't describe how it gets from here to here or from here to here and so on. The second major section of it is how it gets transported. And And that explains, since all these parties have to cooperate in flowing these messages around, how if this is going to redirect you over here, how that redirect should look like, because this person has to know what that redirect is going to look like, and then when it's finished, how it knows where to redirect the user back to, and so on. So there are a lot of other bits of the SAML protocol, SAML specifications, but the two key parts, the payload format and the transport format. And in fact, it's interesting, there are some places where the payload is used, but a completely different set of transports are used. For example, you might be using WS Trust, which is a different set of protocol specifications, but still carrying SAML tokens around. More commonly, you see now SAML being used for both. So the one that you see almost all the time is what's called the passive profile. A profile meaning transport works. And the reason it's called passive is because the player in this game, which is the web browser, is kind of being pushed around by these two parts here. It's not doing anything active at all. It doesn't really understand what's happening. It just says, take me to this website, right? And then, so this person pushes it that way, then this thing pushes it back the other way, and then sometimes, in fact, this one pushes you even back again, and so on. There's a kind of bouncing backwards and forwards. And this is really very classically passive player in that process. And really, 95% of the real deployments in the real world are the passive profile. The other one that is in an interesting state now because of the evolution of mobile computing and things has really made this very interesting now is what's called the active profile. And in that case, what we've got is let's say we have, we have an iPad. Doesn't necessarily have to be an iPad, but a mobile device, some mobile device. They all look roughly like this nowadays. And on here, I actually have, rather than a passive web browser, I didn't really know what's going on, I've actually got a piece of code hosted on here that understands that I'm going to communicate directly with this thing. I'm not doing a web browsing thing here. I'm doing some form of API call.
So a rich mobile app, like
exactly.
Instead of the browser on.
Yes, yeah. So if we take the Salesforce case, this could be either a Salesforce or a third-party application that's explicitly calling whatever the API structure here is, REST API types or whatever they might be. This is an active piece of code specifically written to work in here. It's still got the same problem though. It still needs to authenticate. There's still a user using this application, which has to be authenticated. And within SAML, there's what's called the active profile. And the active profile is all about how this application would go about asking what has to happen is this guy has to ask to get a token from here and then send the token off to this one. Now, this is a very rapidly evolving space. So SAML active profile definitely works here. There's still a few holes in that. There's, for example, the holes particular are the obtaining of a token by the application from the IDP is well specified by the active profile. Sending it from here to here, exactly how that should be sent, is not well decided within the industry at all. Should I send it as part of the URL? Should I send it an HTTP header? Should I make it look like a cookie? There's no universal agreement about how a SAML token should flow there. But there are other protocols in this space, which I'm not going to discuss in detail, but just to mention them by name. The most important one is one called OAuth. And OAuth, again, is designed to address this problem of a rich client wanting to call the application interfaces of another one. Originally, OAuth was much more consumer-focused, SAML very enterprise-focused, but there's a kind of enrichment of OAuth going on. There's still a lot of differences between the two, and there are some other ones coming along. There's one called JWT, which I know is pronounced not like it's spelled like jot, is how you pronounce it. Again, trying to fill the same space as SAML is trying to fill. But for example, just since we're Centrify, Centrify has a toolkit which fits exactly into this slot here to enable you to get tokens and then to send them over here. And we've kind of gone with one of the non-formally standardized ways of presenting tokens over here. But at the same time, we don't force the programmer to send it in a particular way. If this thing is already set up to accept SAML tokens via its API calls, they can send it however they like. So
Well,
those are the two most common use cases you see out there. And but this is by far the most common, 95%, 5%.
Whether it's the passive profile or the active profile, in both cases we're dependent on the service provider to actually support using these tokens and so forth. Is there anything we do to help the ISVs make that easier? You mentioned something about the SDK on the mobile side. Do we offer that same type of help on the service provider side?
So first of all, to answer the basic question, which is this player has to know that they're in a SAML space. It's not something that we can impose upon them from outside. They have to build their security infrastructure such that they accept all this. Because an area we haven't discussed yet, which is how did we establish the trust between the two and so on. They have to do a fair amount of work to do that. A lot of the big SaaS applications, Salesforce will take, already has done that, but there's a lot of applications and that haven't done that yet. Plus, as an aside, although we've been talking about SaaS applications, if I have my own in-house applications, my own HR system, my own CRM system, there's no reason why I can't use this same infrastructure to talk to my own in-house applications. And definitely there's an opportunity to add SAML awareness to those because you get all the additional benefits of not having to maintain your own user database and so on. So certainly, we as Centrify, we have various SDKs all to support various languages, which you can slot into here to help you support different SAML types in different languages, if you're Java or Ruby or PHP or whatever. I mean, there are a lot of libraries out there already. These are not the things we supply are not, anything proprietary. They're just helping you get going and receive the value of SAML.
So the one thing that we haven't discussed is how the identity provider, the IDP, and the service provider, the application, actually know about each other. They know what messages to send to each other and that they can trust those messages.
Okay, so let me just start with my two players again, which is over here we have C1, and then we have their IDP. So what we want to do, if you remember, we won't discuss the exact flow of the tokens. The net effect was this system, in consultation with an identity system in here, produces a SAML token, which I would drew like this. And what we need is, when this token arrives here, that this system can inspect this token and know two things. A, it definitely came from over here, and B, that it hasn't been tampered with since it was issued by this one here. So what happens is the IDP has a cert plus the private key that goes with the cert. This is X509 just to make sure and somehow out of bound from this communication, and it varies from implementation to implementation on this side, this certificate is installed up here. So somewhere within Salesforce, we have the C1 cert. Not the private key, just the certificate. So typically what will happen is, let's say the administrator of here will download the cert from some web page here, go over here and do an upload, or maybe there's some programmatic way it can be done. It varies from provider to provider, the exact nature. The end effect is the same. There's the configuration of that, plus some additional configuration about their customer C1. Remember, he needs to redirect users back over here, so it needs to know the URLs to redirect back to and so on. But for the trust purposes, the key one is this. So when the IDP issues this certificate here, it signs it, and I shall do a little sparkle here to say this is a sparkly signed SAML token saying signed using this certificate. I'd love to go into how digital signatures work, but that's kind of a little out of scope. But the net effect of that is this token, a receiver of it can tell that it was issued by somebody who has the private key that uses this cert, that belongs to this, that goes with this cert. So I know that only the person who has this piece of information could have done it. The first thing. Second thing is I know it can't have been tampered with. That the content, because the contents are signed, it also attests to the fact that the contents are the same as when it left here as when it arrived.
So the only place it could have come from is C1's account, IDP.
Right.
Of
course, the thing is predicated on you keeping that private key private.
Sure.
If this escapes, then who knows what will happen. But I mean, it's well known within the certificate space that you have to keep your private keys private. That's what they're called, private. So it's the nice thing is it's leveraging existing technology. Digital certificates, this digital signing using certificates, and so on. So it's actually a pretty robust and well understood mechanism out there. It's one of the reasons why SAML is relatively easy to implement, because they didn't have to reinvent a lot of trust technologies.
Great. Thank you, Paul. Well, we hope that this has been a helpful video in learning about the basics of SAML and how it's implemented within the SaaS application space. For more information and additional videos that talk about how Centrify implements SAML for all your SaaS applications and more, please visit www.centrify.com. Thanks a lot.